On Wednesday, we talked a lot about solving these equations where there were no numbers, where it was all variables. So if I gave you something like solve ax plus b equals c for x, we had to go through the process of solving it just like if there were numbers in there. The biggest difference is we can't combine the letters. So here, ax plus b equals c. What I usually do is I'll actually rewrite it, replacing every variable with a number except for the variable I'm solving for. So I'm solving for x. I'm going to leave the x alone there, and I'm going to replace everything else with a number. So I might say this is 5x plus 3 equals 33. So now I just kind of look at them, and this equation is going to tell me what I have to do with the variables. So over here, what would I have to do first to solve this one? Subtract 3. So I subtract that 3, 5x equals 30. So over here, what's the equivalent move that I have to do?
Subtract b.
I have to subtract b from both sides. So b is gone, leaving me with ax. The difference is over here, I could do 33 minus 3 and get 30. Here, c minus b is going to have to be left as c minus b. On this side, what's my next move to solve this? We divide by 5. So x equals 6. Over here, the equivalent move is divide by a. So that is gone, leaving me with x. Again, I can't combine on the right side, so c minus b divided by a. I'm going to leave it as a fraction with c minus b over a. And that's it. We looked at ones where one of the variables may have been part of a proportion, or the whole thing was a proportion. If one of the variables is part of a fraction, it's easiest to make it into a proportion. So I'm going to give you one here where it is just a proportion straight out. If I ask you to solve this for v, well, here's v. So to solve it, all I really have to do, since this is a proportion, is cross multiply and divide. What two letters are going to get multiplied here? Well, I treat the v as though it's not there. So there's only two letters that are diagonal from each other if I take out the v. What two letters are they? M and H. So it's m times h. So then what letter is left over that I'm going to divide by?
P.
The p. Very good. So divide by p. So v is equal to m times h divided by p. What if I look at that same equation, that same proportion? This time, though, I ask you to solve it for p. Well, here's p, so I'm going to pretend that the p is not there. What two letters are diagonal again? M and H. So it's m times h. And I'm going to divide by what letter this time? The v. So divided by v. Good. Some equations that we solved that were a little bit out of the usual, we might have had some like this. 4x minus 7 over 3 equals 7. What would we do to solve that? What's our first step?
Everything on top of the fraction bar?
Well, when this was built, yeah, everything on top of the fraction bar had to be done first. Then it was divided by 3. So when we go to take it apart, we reverse that. The last thing that was done building it is dividing by 3. So the first thing to take it apart is to multiply by 3 to get rid of that. So on the right side, 7 times 3 is 21. On the left side, all we've done is remove this 3 here. So we're left with 4x minus 7. Now we're back into that standard form. What do we do to solve it from here?
Add 7.
Add 7. So 4x equals 28, and then divide by 4. Good. So x equals 7. Okay, so I think you guys are doing pretty good with those. So today's new topic, we're going to be looking at graphing. And what we're looking at is we're going to represent numbers visually. Representing numbers graphically. And we talked a little bit way back at the beginning of last semester when we did negatives, the integers. We talked about number lines. And to represent numbers on a number line, we had those vectors that we could use. If I wanted to represent a 6 on a number line, I could use that vector that went from 0 to 6. But if I'm going to work with them and do operations with them, that's a very good operational visualization of 6. But if I'm going to just display a bunch of numbers on here, that gets cluttered very quickly. So another way to display 6 is just to put a dot at 6 like that. So I can actually plot several numbers on this single number line by just putting dots at their value. But in math, a lot of times what we're looking at is a relationship between two numbers. So not only do we want to represent the value of the number, but we also want to represent that relationship between the two numbers as well. And to do that on a number line would be really tough. Let's say we wanted to do 6, 2. We wanted to represent that relationship. We've already represented the 6. We can represent a 2 like that, but to show a relationship between them is tough to do. I suppose I could maybe show an arrow or something like that. But again, that would get cluttered very quickly. So a couple thousand years ago, a man by the name of Rene Descartes came up with an idea. And his idea was just this. If I want to represent two numbers and the relationship between them, I'm going to use a number line to represent one of the numbers, but then I'm going to use a second number line for the second number. And what I'm going to do is, in order to make it so that one single dot can represent both numbers, Descartes put the second number line vertically instead of horizontally. So on the original number line, of course, positives to the right, negatives to the left. This vertical number line, positive is going up and negative is going down. So to represent 6, 2, well, we got to figure out which one's going to go first. Well, this first number line, the horizontal one, is often called the x-axis. Now, a lot of times we call that not just the x-axis, but sometimes called the independent axis. If we're looking at statistics, that's the axis that is the kind of the cause variable. It's the one that we can vary and make it whatever we want to. It's the one that we're exploring. This vertical axis is often called the y-axis. It represents the y variable, and it's often called the dependent axis. It's called dependent because oftentimes its value depends on what the value of the x variable was. So now here, this item here, we have the 6 and the 2. We refer to that as an ordered pair. It's a pair of numbers and they're in a specific order. The order does matter. The first number has to come first. And what we do is we list them alphabetically. That's the x variable. This will be the y variable. So the 6 is represented on the x-axis. So 6 on the x-axis is going to be right here. The 2 is represented on the y-axis. That is right here. Well, we need to be able to represent both of those values at once with a single point. And the way we do that is just this. We extend them out. We put 1 point out here in space. The shadow of that point falls on 6 on the y-axis and 2 on the x-axis. So that is 6 on the x-axis and 2 on the y-axis. So that's the point 6, 2. Now there is some vocabulary here related to this that we can talk about. The point in the center here where the two number lines cross, where the two axes cross, that is the coordinate 0, 0. It's 0 on both number lines. That is given the name the origin. It's called the origin because both number lines start there. Everything starts from that spot. When we get into graphing, the graphs start at that spot and move up, down, left, right from that point. These 4 sections of the graph are called quadrants. This is quadrant 1 up here because both x and y are positive. And that's usually the first quadrant that we use. Generally, we're dealing with positive numbers. That's the first one that gets used. This one then is called quadrant 2. There's really no good reason why that's quadrant 2 other than there are a lot of things we do in trigonometry and navigation and stuff like that where we start at a point and we go counterclockwise. So we call that quadrant 2 just because we go counterclockwise. That would be the next one. Then this, of course, is quadrant 3. And this would be quadrant 4. So 6, 2 is in the first quadrant because both x and y are positive. So let's look at some points on the graph here. I'm going to put a couple on here. I'm going to change colors so it's a little bit brighter. I'm just going to draw lines out. Drawing dotted lines is too tedious. What would that point there be called? Well, what's its x coordinate?
-5, 4.
Perfect. The x coordinate is -5, and yes, the y coordinate, to trace it over, is 4. So that would be called -5, 4. So then over here, let's put on this one. What's the coordinate for that point going to be called? -3. You got the right idea. -7. So it's -5, -6, -7. And over here, how about that point? What's that going to be called? 4. What's the other point? -2. Good. So we can put those points, we can find those points on the graph. Now, like I said, these can represent a lot of different things. They can represent time and work accomplished or time and money earned, supplies left in time or supplies consumed in time. There's all sorts of things they can represent. It also is often used for laying out a job site. They use a coordinate system like this for the landscaping, saying that this large major tree is going to be located at position 7, 2 on the grid or whatever. Now, some trickier points to put out. I want to make this point right here in purple. What is the coordinate for that point? Somebody said it there, 3, 0. Good. Because it's at 3 on the x-axis and at 0 on the y. So, there you go. So if a point is on one of the axes, one of the coordinates is going to be 0. So how about right here? What is this point going to be called? Careful.
0,
-0, -4. There you go. You had the right idea. I knew what you were thinking. How about this one?
0, -6, or -6, 0.
-6, 0. Good. So we can plot individual points, and there are several applications where plotting individual points on this graph are useful. One of the things we're going to use it for is we're going to use these graphs for expressing the solutions of an equation. You know, we've seen equations like this: 3x plus 1 equals 10. We solved it by subtracting 1. 9 equals 3x, and dividing 3. So 3 equals x. Well, similar to that, we could have 3x plus 1 equals 16. If we look at this equation, we see that it's very, very closely related to this first one. The steps for solving it are going to be exactly the same. We're going to subtract 1, gives us 15 equals 3x, and again divide by 3. So 5 equals x. In fact, I can write any number of equations that look like that. I'd have 3x plus 1 equals 4, or 4 equals 3x plus 1. Again, I'm going to solve it by subtracting 1, 3 equals 3x, and dividing by 3. I get 1 equals x. Well, this is what we call a family of equations, because I solve all of those equations with the exact same process. And the reason is this side of the equation looks exactly the same. All of them are 3x plus 1. And like I said, there's an infinite number of equations I can write of that form. 3x plus 1 equals a number. So in order to express that family of equations, we write it like this: y equals 3x plus 1. So we've now taken out the one number and we've put in a second variable. And y equals 3x plus 1 has an infinite number of solutions. For any number I choose for y, I can find a number for x that makes that true. It's often easier to look at it the other way around. For any number I pick for x, I can find a value of y that makes it true. So let's do this. I'm going to start out, I'm going to make a table, and I'm going to pick values of x. And I am going to then figure out what value of y makes that equation true. The reason I'm picking values of x here is because since y is equal to 3x plus 1, once I know the value of x, it's relatively easy to find y. If I picked values for y and I went the other way, it'd be a little bit more work. So let's say I pick x to be -3. I'm just going to pick some values for x. I do -3, -1, 0, 1, and +3. The only reason I did that is I just want a variety of numbers scattered across a range. So now let's see, when x is -3, what does y have to be? Well, I'm going to replace the x here with -3. So this is 3 times -3 plus 1. What is 3 times -3? -9 plus 1 is? -8. Very good. What I've actually done here is I have formed an ordered pair. When x is -3, y is -8. So on the graph, there's -3 for x. 1, 2, 3, 4, 5, 6, 7, 8. -8 for y. That's a point on my graph. -3, -8. I'll slide that over just a little bit. Make it work. Right about there, looks better. Now for -1, if x is -1, I replace x with -1. So 3 times -1 plus 1. What is 3 times -1? -3. -3 plus 1 is? -2. So we get the ordered pair here. X is -1 when y is -2. So x is -1, y is -2 is right there. if we put in 0 for x, so it's 3 times 0 plus 1. What is 3 times 0? 0 plus 1 is 1. So we get the ordered pair x is 0 when y is 1. So x is 0, y is 1. It's right there. So now if x is 1, let's see what we get. So we put 1 in for x. This is going to be 3 times 1 plus 1. What's 3 times 1? 3 plus 1 is 4. So I get the ordered pair. When x is 1, y is 4. So here's x is 1, y is 4 is right there. Next, I get x is 3, so it's 3 times 3 plus 1. What is 3 times 3?
9.
9 plus 1?
10.
10. Good. So I get the ordered pair when x is 3, y is 10. So x is 3, 10 is probably somewhere in there. What we notice here is that this forms a line across our graph. This is what we call a linear equation. It's called a linear equation because it forms a line. Okay, Mr. Berghammer, do you have those worksheets with the graphs on them?
Yeah, no problem.
Okay, I'll have you hand those out to him quick. So what we're going to do now for the next section of class here is we're going to see several graphs that we're going to go through and we're going to fill in the table. And we're going to kind of go point by point. I'll give you guys a couple seconds to try to figure out what the point is. And then we'll go ahead and do it just to make sure you're on the right track. Okay, so the first one on this worksheet is very, very similar to the one we just did. Y equals 3x plus 2 instead of y equals 3x plus 1. So I gave you here a table where I have negative 2 for x, negative 1, 0, 1, and positive 2. So I gave you those values for x. Now, in order to fit them on the worksheet, I cut you a little bit short of space for y. Normally, we would just have y here, and we'd figure out its value from going off to the side. So what we need to do here is we need to find this value of y. That value of y, of course, comes from the fact that x is negative 2. So we fill in negative 2 up here for x in the equation. So instead of 3 times x, it is 3 times negative 2 plus 2. What is the value of 3 times negative 2 plus 2? Negative 4. Very good. 3 times negative 2 is negative 6 plus 2 is 4. So that is giving us a point on our graph. X is negative 2 and y is negative 4. So there's x is negative 2, y is negative 4. There's a point right there. So I'm going to give you a couple of seconds here. Try to figure out what the value of y would be when x is negative 1. And plot that point on the graph quick. So if x is negative 1, y is going to be 3 times negative 1 plus 2. Careful. Negative 1, there you go. So that gives us that ordered pair. When x is negative 1, y is also negative 1. So x is -1, y is -1 is right there. Do the same thing for 0. If x is 0, figure out what y has to be. Okay, so when x is 0, y is 3 times 0 plus 2, which would be what? 2, good. So now we have, when x is 0, y is 2. So x is 0, y is 2 is right there. Let's keep it down, guys. Hands to ourselves. So when x is 1, what's y have to be? 5. Very good. So that gives us the point. X is 1, y is 5. So 1, 5 is going to be right there. And finally, there you go. When x is 2, you're absolutely correct. Y would have to be 8. 3 times 2 is 6, plus 2 is 8. So that gives us the point. X is 2, y is 8. So x is 2, y is 8 is right there. Once again, this forms a line on our graph. Now, not all of our equations are going to form a line. Now, for right now, I'm going to skip number 2 on this worksheet, and I'm going to jump to number 3, because I think you guys could probably do number 2 on your own. If we get time, we'll come back to it. But I want to make sure we get to some of these other examples. So we're going to jump to number 3 here. Number 3, y is equal to x squared plus 2x plus 1. So in my table, we start out with x equals -2. Now you would need, most likely you wouldn't be able to do this right in the table on the graph. You would need some extra paper to fill this out. Y is then going to be found by replacing x up here with -2. So y equals x squared becomes -2 squared plus 2 times x becomes 2 times -2 plus 1. So now it's order of operations going across here. What is -2 squared? +4. Good. Make sure you have parentheses around it on your calculator, or your calculator might try to tell you it's -4. Plus, what is 2 times -2? You do 2 times -2, it's going to give you a -4, right? Then plus 1. So now what is 4 plus a -4? 4 plus -4 is 0. Plus 1 is 1. So here, when x is -2, y is a +1. So there's a point right there. So now let's do, it says -1 is the next value of x I should use. So let's see what we get for -1. So we've got -1 squared plus 2 times -1 plus 1. Okay, good. -1 squared is 1. 2 times -1 is -2. We got the plus 1. So what is 1 plus -2? -1, and -1 plus 1? 0. So when x is -1, y is 0. So x is -1, y is 0. That's right there. So now we're going to do x is 0. So if we put in x is 0 here, it's 0 squared plus 2 times 0 plus 1. This one's not so bad. What's 0 squared? 0. What's 2 times 0? 0. So 0 plus 0 plus 1 is 1. Okay. So when x is 0, y is 1. So x is 0, y is 1. Looks right there. But we can see already from just those 3 points, this is definitely not going to form a line. It's going to form some other type of curve. So let's do x equals positive 1. For x equals positive 1, x squared is going to be 1 squared, plus 2 times x will be 2 times 1, plus 1. Oh, yeah, they got, it's, what happened there is when I printed up this worksheet, the automatic numbering kicked in for some reason, and it changed the 0 to a 3 and the 1 to a 4. You can cross off the 3, 4, and 5 and put in 0, 1, and 2. Yeah. I'm on number 4, actually, though we will keep some of those weird numbers that we have in there. So anyway, if x is 1, what's 1 squared? 1 squared is 1, right? 1 times 1, or 1 times 1 is 1. 2 times 1 is 2. Then we got the plus 1. 1 plus 2 plus 1 is 4. So we have when x is 1, y is 4. So here's x is 1. 1, 2, 3, 4. Y is 4. Is right there. That's out of there. So let's try x is 2. Seems to be the next one to try. So we're going to have 2 squared plus 2 times 2 plus 1. What is 2 squared? 2 squared, 4, good. What's 2 times 2? 4, okay, plus 1. So 4 plus 4 plus 1 is 9. So this gives us the ordered pair of 2, 9. So when x is 2, y is 9. It's going to be right there. Well, we get a good idea that this part of the graph looks something like that. But we're not so sure what's going on over here quite yet. So what I'm going to do is, now that I've plotted those points, I'm going to pick more points over here to kind of figure out what it looks like over here. And a lot of times this is what we have to do when we're graphing by tables like this, is we get some points on the graph, but they're not enough to figure out what the shape is, but they tell us where we need, what values of x we need to use to find the rest of it. And here I would say, if we picked x to be -3, it's going to give us a point over here somewhere. And that'll help us figure out what this graph should look like. So let's go back and use x is -3. So if x is -3, this is going to be -3 squared plus 2 times -3 plus 1. What is -3 squared? 9, good. What is 2 times -3? -6, and of course we have plus 1. What is 9 plus -6? 9 and -6 make +3, good. 3 plus 1 is 4. So that gives us the ordered pair when x is -3, y is 4. So on my graph, x is -3, y is 4. It's right there. Now we get the idea that's what our graph looks like. This shape here is what is called a parabola. That's the shape that we typically get when our equation is y equals x squared of some form. Yes. This worksheet is not graded, but there's going to be problems on one of your quizzes coming up next week that are going to look very, very similar to it. Okay. Any questions on number 3? So as you can see on that one, I kind of pick some standard points and graph them. But once you've graphed them, that may not be enough. You have to look at the graph and figure out what values of x do you need to use to try to figure out the rest of that graph. Number 4 is a little bit of a different example. For number 4, it helps if we look at it and try to figure out what values of x are going to work good, work good, there's my great English there, are going to work well within that equation itself. So looking at this one, I put some really weird values in there for x for you. I believe the first one I put in is -6. When I'm looking at this equation, I see that I'm going to take x plus 6, and then I'm going to have to take the square root of it. Well, we know that numbers that square root easily, well, we can get the square root of 0, we can get the square root of 1, we get the square root of 4, we get the square root of 9, the square root of 16. Those are all numbers that have a nice, neat, perfect square root. Now, we don't have to have a neat one, but if we were to just pick a random number, let's say we just picked like 0 for x and put it in there. I'm going to erase this, so don't write it down anywhere. If x were 0, y is going to be the square root of 0 plus 6. Well, that's going to be 0 plus 6 is 6. That's the square root of 6. So second square root of 6, that's 2.4495 basically. Well, if I wanted to try to graph that on here, x is 0, y is 2.4495. Well, where on earth is the 0.4495? Well, I can put a dot in there, but it's going to be approximate. So it's a lot easier to graph if I pick values that are going to give me integers for y. So the first one I chose there is -6. The reason I chose -6 for x is because if I put x in here, what's -6 plus 6? 0. So that's one of the first ones on my list here that I know gives me a nice, neat answer. So if x is -6, y is -6 plus 6, which is 0. So what's the square root of 0 is 0. So that gives me that ordered pair when x is -6, y is 0. So that's a point right there. Now the next one I gave you, let's look up here. The next perfect square would be 1. What value could I pick for x that would make x plus 6 be 1? Well, I believe I gave you -5, correct? So that means this is the square root of -5 plus 6. What is -5 plus 6? 1. And what is the square root of 1? 1. So that gives us the ordered pair when x is -5, y equals 1. So x is -5, y equals 1, right up there. So that gives the 1. Next one that gives us a nice even square root is if that is 4 under there. So what plus 6 would be 4? I think I gave you -2 for that one. So what is the square root of -2 plus 6? Well, first off, what is -2 plus 6? -2 plus 6 is 4. And what is the square root of 4? It's 2, right? So that gives us the ordered pair, -2, 2. So at -2, +2 is like that. Next value I'm going to use for x is 3, a +3. So now I have x is the square root of 3 plus 6. And of course, what is 3 plus 6? Is 9, and the square root of 9 is 3. You are correct. So when x is 3, y is also 3. I put that point at the wrong spot, didn't I, here? That should have been -2, 2 would have been there. X is 3, y is 3 would be up here. So I can get a picture of my graph that looks something like that. Now, if I look at my graphs that I did up here, this one here you can see I put arrows on both ends of it. This one here you can see I put arrows on both ends of it. This last graph I did down here, I only put an arrow on this end. I did not put an arrow on this end of it. The reason I didn't put an arrow down here is because this is a square root. And when x is -6, -6 plus 6 is 0. I can take the square root of 0. But if x were -7, that would be the square root of -7 plus 6. Well, what is -7 plus 6? -1. What's the square root of -1? Your calculator says error, right? Yeah, we can't do it. It turns it into, if we were to get into advanced algebra, it turns it into an imaginary number. You cannot take the square root of a negative number. So that's why this line here, instead of having an arrow on the end, is just a dot, because I cannot keep going to the left. X cannot keep getting smaller. X cannot be any smaller than -6. That's what we call an asymptote. An asymptote is a limiting factor on the graph. The graph cannot go past that point or through that line. And this graph has an asymptote. Okay, it is 2:43. It's break time, so let's go ahead and take 3 minutes, and we'll come back and get back to work. We're going to flip over to the back side of the worksheet, and we're going to look at number 6 next. Now, the equation for number 6 is y equals 2 to the power of x. So if I have x equals -2, y is equal to 2 to the power of -2. So now we got to be careful punching this in our calculator. 2 to the power of, you have to make sure you use the negative key and not the minus key. So -2, it gives us 0.25 or 1/4. So when we go to plot that on our graph, so we've got x is -2, y is 0.25. So there's -2, 0.25 is going to be somewhere in there, about 1/4. Again, you can see when it's not a whole number, it gets to be tough to graph. If x is -1, let's focus a little bit, guys. So it's 2 to the power of -1. What do we get for 2 to the power of -1? Oops. 2 to the power of -1 is what? Two to the power of -1, 0.5, 1/2. Very good. So we've got this ordered pair. negative 1, and 0.5. So x is negative 1, y is 0.5 is right there. Okay, guys, let's focus on this class for now. So when x is 0, y is 2 to the power of 0. What is anything to the power of 0? Not 0. There you go. Somebody said it. It's 1. Very good. So we get the ordered pair when x is 0, y is 1. So 0, 1 is right there. So next, how about when x is 1? Y is going to be 2 to the power of 1, which is 2. Good. So it is 2. So when x is 1, y is 2. So x is 1, y is 2 is right there. When x is 2, y is going to be 2 to the power of 2. 4. Good. So we've got 2 to the power. We get the ordered pair. X is 2 and y is 4.
It just doubles.
It's going to double every time, exactly. And this is what we get a curve. It looks something like this. This is what we call an exponential curve. And on an exponential curve, every time we move one spot to the right, it increases by a set factor. This is 2, so it would double every time. If that were a different number, it might triple or quadruple every time. Or it might get cut in half or cut to a third each time. So that exponential curve looks like that. And one common thing about these exponential curves is, like we saw up above, these have an asymptote. The asymptote for this is actually the x-axis. The value of y can never be 0. There is no number I can put in here for x that will make 2 to the power of x be negative, or even make it equal 0. It'll never equal 0 even. Okay, any questions on that one? Okay. So now we're going to jump down to problem number 7. I'll wait for you to get back to your spot there. Okay, problem number 7. Y equals x cubed minus 1. Okay. So we got x is negative 2 is what we're starting off with. If x is negative 2, y is negative 2 to the third power minus 1. What's that come out to be?
Oh, negative 6 minus negative 7.
Careful.
Negative 6.
Negative 2 to the third power, remember, is negative 2 times negative 2 times negative 2, right? That ends up being negative 8 minus 1 is negative 9. You had the right idea there. So that gives us the ordered pair, and x is negative 2, y is negative 9.
Is the next one going to happen to be 1? Or 0?
Yeah, you're on the right idea. You're on the right track, but you're a little bit off there. So x is negative 2, y is negative 9 is going to be right down here. So let's take a look at that next one. If x is negative 1. If x is negative 1, y is then going to be negative 1. Okay, guys, there's a lot of chatter coming back through the network, so I can't hardly hear anybody talking, so I have to keep it down a little bit, okay? So we've got negative 1 to the third power, which is what?
Negative 1.
Negative 1, good. Negative 1 minus 1?
0.
Negative 2. There you go. So when x is negative 1, y is negative 2. So negative 1, negative 2. So if this is 0, you've got I think you're on the right track there. What's 0 cubed? 0 minus 1, of course, is negative 1. So you're right on there. When x is 0, y is negative 1. So x is 0, y is negative 1. Now we can see there already this is not straight. These 3 points do not line up. So this is not going to be a line. How about when x is 1? Well, y is going to be 1 to the 3rd power minus 1. What is 1 to the 3rd power?
0.
You got it. 1 to the 3rd power is 1. Minus 1 is 0. So you are correct. When x is 1, y is 0.
What was the answer?
So when x is 1, y is 0 right there. So then next, when x is 2, okay, yep, you've got it. Let's walk through it, though, to get there. So 2 to the 3rd power minus 1. 2 to the 3rd power, of course, is 8. Minus 1 does give us 7. So you were right. So the ordered pair 2, 7. So x is 2, y is 7. So this graph looks kind of like an S shape like that. And this is sometimes referred to as a cubic curve, a simple cubic curve. And that's because it's a power of 3 on our variable there. Okay. The last one that's kind of unique is going to be number 8.
Oh, yes. It's my favorite one.
There are actually some kind of weird things going on with number 8 here.
What's 8 divided by 0?
Good question. It actually is not 0.
It's not 0, guys.
Let's take a look at the numbers that are on here first and see what happens. So if x is negative 2, y is going to be 8 divided by negative 2. What's that going to be? Negative 4. Good. So that gives us the ordered pair. Let's focus. You only got about 15 more minutes, guys. So when x is negative 2, y is negative 4. So we've got negative 2, negative 4 is right in here. I'll slide that over just a little bit. So then when x is negative 1, y is going to be 8 divided by negative 1, which is what? Negative 8. Good. So x is negative 8, y is negative 1. Or sorry, when x is negative 1, y is negative 8. It's right there. So now here's the one you brought up. When x is 0, y is going to be 8 divided by 0. What is 8 divided by 0?
It's an error.
It gives you an error. It's undefined. We cannot divide by 0. If we allow ourselves to divide by 0, some really strange things happen. So x can never equal 0. So let's keep going, and we'll come back and we'll address what do we do at 0 then. If x is 1, yep, and you've got that. 8 divided by 1 is 8. So yes, that is the ordered pair. X is 1, y is 8.
The next one's going to be
jump. Thank you. So this one jumps all the way up here. So it looked like our graph was moving down here, then it jumps up. And now you said that when x is 2, of course, 8 divided by 2 is 4. So we get the ordered pair, x is 2, y is 4. So we appear to be coming back down again. Well, we don't have enough points here to really know what's going on yet. We need to know what's going on over here, and we need to know what's going on over here. So I'm going to use -4 and -8. The reason I'm using -4 and -8 is I know they divide into 8 really well. So let's use x is -4 and x is -8 quick and get those points. If x is -4, if x is -4, what is y?
-2.
Perfect, -2. So you got -4 and -2. So now the next one, yes, if x is -8, y is 8 divided by -8, which would be -1. You are correct. So if x is -8, y is -1, that's right here. So that's showing us that on this side of the graph, it appears to be giving us a curve, something like this. Let's see if we're getting the same thing over here. So on the right side, I'm going to use x is 4 and x is +8 and see what happens. When x is a +4, what do we get for y? 2, good. So x is 4, y is 2. X is 4, y is 2 is right there. Next, when x was 8, y is 8 divided by 8, which is 1, good. X is 8, y is 1. So x is 8, y is 1 is right there. So this appears to be shaped something like this. This graph actually has 2 asymptotes in it. The first one is a result of this. X can never be 0. So it gives us an asymptote right here where x is 0. Remember that y-axis, everywhere on that y-axis, x has a value of 0. So this graph can never cross that y-axis. So what happens is it shoots way off down to -infinity here on the bottom of the graph. It shoots way off up to +infinity over here, but it can never actually cross it. It can never actually touch x equals 0. Then there's a second asymptote right here. No matter how far negative we get, this is never going to get up to 0. And no matter how large x gets here, 8 divided by x is still going to be greater than 0. So this line will never cross either axis in this case. So x can never be 0, and y will end up never being able to be 0 as well. So here we have a graph that ends up being in 2 very, very separate pieces. Okay, so those are the different forms of graphs. A couple little things. We're going to start the quiz in just about 4 or 5 minutes, just so you guys know. But I just want to look here at number 9. Y equals 4x squared minus 8. Now, we've done several examples so far. This equation looks similar to one of the examples we've done. And why it looks similar is right here because of the x squared. Looking back at the examples we've done, which one of them, 1 through 10 here, also has an x squared in it?
Number 3.
Number 3, good. And what shape did number 3 make? That parabola, that funny U shape, like that. So we know that number 9 here, when we graph it, is going to make a shape similar to that. And what that does for us is that helps us. Because now once we pick a few points and get them on the graph, like -2 is going to end up being If x is negative 2, y is going to end up being 8. If x is negative 1, y would end up being negative 4. Once we get a couple of points on the graph, we know that it's going to form this parabolic shape, this U shape. So it helps us figure out where to choose the rest of the points to try to fill in that shape on the graph. Number 10. Y equals 3/4 x minus 4. There's nothing going on here. There's no square root. There's no power on the x. Nothing funny. So one of the things we're going to start out talking about next week, Wednesday, is we're going to talk about identifying which equations are going to form lines. And this one is definitely going to form a line. Now, one of the things about it is once we know it's going to form a line, we no longer have to graph 5 points. Technically, once we know it's a line, all we have to do is graph 2 points. You know, let's say I pick x equals 4. If x is 4, well, 3/4 times 4 is 3, minus 4 is negative 1. So if x is 4, y is negative 1 right there. My second point, I might pick x is equal to 0. Well, if x is 0, 3/4 times 0 is 0, minus 4 is negative 4. So I've got 0, negative 4. Once I have 2 points, I can draw my line through it, and there's my graph. That's all I need if I know it's a line. Now, I might be, just to be safe, I might pick a third point. I might try x is 8. 3/4 times 8 is 6, minus 4 is 2. So at 8, make sure that that does actually come out to 2 when I graph it. So if I put that point down there, make sure that all 3 of those are still in a line. But knowing the shape of the graph saves a lot of time in graphing it. In fact, for lines and parabolas, once we know that's its shape, there are some really extreme shortcuts we can take. And what we're going to focus on this class, we're not really going to get into the parabolas, but we're going to focus on lines and the shortcuts we can take to make it really quick to graph a line. Okay, that is it for the new material for today. Your homework, there are a few equations on this worksheet. I think there's 3 or 4 of them that we did not graph. Looks like 4 of them that we have not graphed yet. Your homework is to finish graphing those 4 equations on this worksheet. And then we're going to have Mr. Berghammer in the room there. Or did he guys give you the quiz? Did he leave the quiz for you guys? Okay, if you guys want to grab the quiz and get started on the quiz then. I'll let you guys have this last 20 minutes to work on the quiz and then finish off that worksheet. Yes.